Welcome back. This is an Aleks training video on using heat of fusion or vaporization to find the heat needed to melt or boil a substance. Heat of fusion is melting. Heat of vaporization is boiling. Okay, so you are going to have energy that makes it hotter. Okay, their energy is required to make water hotter, to go up from 17 degrees to 18 degrees. But you're also going to need energy just to melt the ice to go from solid to a liquid, or to take 100-degree water and turn it into 100-degree steam. So you're going to need energy to turn 0 degrees ice into 0 degrees water, and then you're going to need energy to turn 100-degree water into 100-degree steam. That's called the heat of fusion for melting, the heat of vaporization for boiling. Then you're going to need a certain amount of heat to raise every gram of water 1 degree Celsius. Okay, and that's called the specific heat of water. If it isn't water, you're going to need to be given the heat capacity for whatever material it is. The specific heat of water is 4.184 joules for every gram per degree Celsius or Kelvin. Okay, the stuff I've got here in red is found in your data file. So when you go to the Aleks data button on the toolbar, you can find all this information. All this is going to be at your fingertips. So since it says at the top it's kilojoules per mole, I can't use grams. I have to have moles. All right, so I need to take this 139 grams of ice. Okay, so 139 grams. And water, if I do the molar mass of water from the periodic table, you have to add all the numbers, 18.0153 moles. Grams per mole, which equals 7.715663908 moles of water. Okay, so once I know the water, I need to know, so for every mole of water, it's going to take 601 up here, 601 kilojoules for every mole of water. Okay, so let's multiply that. I'll do that in red. Times 601 kilojoules per mole just to melt the ice. So this is the heat of fusion, just to melt the ice. Okay. So it's 6.01. So that gives me 46.371140009 kilojoules. Now this is one of your answers that you're going to have to add at the end. So some of this energy is just melting the ice, then the rest of the energy is getting that ice up to 90 degrees. Okay. So what's the second one? It says specific heat of water is 4.184 joules for every gram. Okay. Now notice that my first answer was in kilojoules. So I'm going to have to either get them all in joules or all in kilojoules, because I can't add joules to kilojoules, and I'll do that at the end. So we're going to say, how much temperature is it supposed to raise? Okay, so it raises from 0 up to 91.1 Celsius. That's the same as Kelvin. Okay, so it's 90.1 Kelvin. All right. So if you look at the specific heat of water again, it's joules per gram. So I don't need moles like I did before. I just need grams, and so I already have 139 grams. So I'm going to start again. So this is the amount of energy it takes to raise it all the way up to 90. So it's going to be 139 times the specific heat of water, which is grams, 4.184 joules per gram per Kelvin, so grams will cancel, and then we're going up 90.1 Kelvin. Okay, now kelvins will cancel. So your answer should be in joules. All right, so that's going to be a lot of joules. 5.23999 times 10 to the 4 joules. Right? When I divide this by 1,000, I'm going to end up with 52.3999 kilojoules. All right. This is the second number that I'm going to add together. So the first one up here is just melting the ice, and the second one here is getting that ice up to 90 degrees. So let's add them together. I get 98.77113009 kilojoules. Now look for units. I've got 90.1, that's 3, 139, that's 3, so I need to do it in 3. Okay, so 98.7, and then that next 7 brings it up, so it'll be 98.8 kilojoules of energy. That's how much it takes to melt 139 grams of ice and bring it up to 90.1 Celsius.